Hello again, Algebra 1. This is Miss Doolittle, and these few slides, we've only got 4 slides, including the title, so hopefully this one will go kind of quick, is on multiplying binomials. So remember, just like a bicycle has 2 wheels, binomials are going to contain 2 terms, okay? All right, here we go. So this time, in the previous video, if you watched that about multiplying a monomial times polynomials, we talked about the distributive property. Well, here's the thing. When we are multiplying binomials, we are also going to use the distributive property. And then I am ultimately going to show you a second method that often gets referred to. So I really want to show it to you, not so much because I prefer the method, but because I know you're going to hear it in the future. So we'll address that too. But anyway, let's start with the distributive property because that's actually the reason that that shortcut, the other method exists, okay? All right, so here's the deal. Basically what happens is when we have a binomial times a binomial, what that means is I actually have 2 different terms that I'm going to have to distribute, okay? So just like in the previous video when we would take the single term that was outside the parentheses and we would distribute it through a set of parentheses, we're going to create 2 problems like that basically, but then but just have a big string together of those 2 problems. So here we go. Here's what this looks like. We are going to have to first take this A, so from up here, and we are going to have to multiply that by everything in this set of parentheses, so A plus 3. Then we are going to take this piece, the symbol in front of it and the value that's in this spot, and we're going to drop it down right behind. So we're going to take that minus 5, and then we have to multiply that by this entire set of parentheses, okay? Pardon me. So here we go. I'm actually going to erase those arrows because they're kind of in my way. There we go. Now, we literally are just doing the distributive property twice, okay? So we're going to take A times A. Of course, this is A to the first times A to the first, which is A squared, or A to the second. And then we're going to multiply A times 3, put down our plus sign. A times 3 is 3A. And we're finished with that first component. Now we're going to move to this second thing that has to be distributed. So this is a negative 5 times our A, all right? It's important that this negative stays attached to the thing that is right behind it, and we're going to distribute the negative through that set of parentheses just like we distribute the 5, okay? So negative 5 times A is negative 5A, all right? And then we have to go back and do negative 5 times 3, which is negative 15, okay? Now, if you watched the previous video, you heard me say several times at the end of those problems, all right, now I need to go back and check and see if we've got any like terms here to combine. In order for things to be like terms, the variables and their exponents must match identically, right? Well, guess what we have here? We've got an A squared, and I don't see any more of those. But this is an A to the first power, and this is an A to the first power. I have 2 terms where the variable and its corresponding exponent match identically. So I need to combine those guys, okay? So my A squared remains an A squared. Now this plus 3A to the first and minus 5A to the first, so I've got 3 positives and 5 negatives. I don't know if you guys have heard me talk about this way before, but I usually talk to students about combining those integers as either battles or teamwork. The 3 is on the positive team, it's wearing the positive uniform. The 5 is on the negative team, it's wearing the negative uniform. So there's more, they're going to be in a battle, right? It's not a teamwork because they're on opposite teams, so they're going to be kind of battling against each other. So, and the negatives are going to win because I have more of them. How many more? 2 more. 2 more A's, and of course that's actually an A to the first, but we don't have to show the first. So, and then my minus 15 gets dropped down, and that's it. That's how you multiply binomials. Now, that being said, I think I'm going to switch the color of my ink, and I am going to show you this thing called FOIL, okay? I'm actually going to take just a moment and I'm going to copy this thing and repaste it so you don't have to look at my chicken scratch. We are going to rework this same problem using this FOIL method. Personally, I prefer just using this distributive property. That's where FOIL comes from anyway. So the distributive property is the mathematical foundation for this. If you want to call it a shortcut, I guess you can call it a shortcut. I don't think it's that much shorter personally, but anyway, I know you're going to hear about FOIL later on. So here we go. So the F stands for first. The O stands for, outer. The I stands for inner, and the L stands for last. Now, let me show you how we are going to apply this. And I still need even more room. All right. Okay, so here we go. When you see the F for first, what that means is you're going to take the first term times the first term. So the first term of the first set of parentheses times the first term of the second set of parentheses, okay? So basically, if you go back and look over here, that's just my A times A that I did before using the distributive property, right? And A to the first times A to the first, of course, is A to the second power. And I'm going to erase that and lower that down because I'm going to need a little bit of room underneath my original expression. So let's try that again. A to the second power. There we go. Now, O stands for outer. So that basically means my two outside, my outermost terms, I'm going to multiply those guys together. Okay, so that's A times 3, which of course is 3A. The I standing for inner, now I'm going to multiply my two innermost terms. So negative 5 times A, of course, is negative 5A. And the L stands for last. So that means the last term in the first set of parentheses times the last term in the second set of parentheses. Negative 5, remember that negative has to stay attached to whatever's behind it. Negative 5 times 3 is negative 15. Just like before, we need to combine our like terms. Whoops. And that's supposed to be a negative 2a. Wrote down the wrong symbol. Let's try that again. So just like before, my negative team wins. I have more negatives, so that's negative 2a, and it is a battle. So my negative team wins the battle. And then minus 15 at the end. Okay? And there you go. We got the same thing both ways. So you can see over here and over here, they match. And they should always match, right? So this is strictly using the distributive property. This way is using FOIL, okay? Math teachers all over the place, myself included, refer to FOIL on a regular basis. Once you get to Algebra 2 and I teach honors pre-calc, and we'll say, okay, so you just FOIL those guys together. And when we say that, that's what we mean. That's the reason, even if you like this distributive property way better, it's a little bit more writing, but you're going to see in the next video where that pays off, okay? But nonetheless, I wanted you to see what this FOIL business is, because you are going to be hearing about it in the future, okay? All right, here we go. So again, I am going to choose two different ways to work this out. First, I'm going to let you guys pause the video and work this out in whichever way you would like. Go ahead and press pause now. Okay. All right, so I am going to start off using the distributive property twice. So that means I take my first term here, 4y, and I multiply it by this second set of parentheses times y minus 2, okay? Now I'm going to take this second term, the negative and the 1 together, and I'm going to write that behind that first set of parentheses, meaning this set of parentheses in this case, and I am going to multiply it by my y minus 2 because the negative 1 has to get distributed as well. So we've got y minus 2 back here. Now let's go ahead and do our distributing. 4y times y, 4y to the second power. Don't forget, we have to add those exponents together. 4y times negative 2. 4 times negative 2, of course, is negative 8. And then we have to have that y in there still. Now we have to take negative 1 times y, which is just a negative 1y. Of course, that's a phantom 1. It doesn't have to show up, but I thought I would show it for you. And then negative 1 times negative 2. Negative times a negative is positive, and 1 times 2 is 2. Okay? You're going to notice, just like in the last problem, we have got some like terms in the middle of this thing. So my 4y squared remains a 4y squared. Now this time, these guys are both wearing the negative uniform. They are on the same team. So they're going to be working together. This is teamwork. So when people work together and there's teamwork, they kind of make themselves stronger, right? They benefit from one another and make themselves stronger. It's not a battle at all. We're working together now. So when we have 8 negatives and 1 more negative, that's going to be 9 negatives all together, of course, with that y still being multiplied at the end. Now I do still have my plus 2, no like terms for that. So there we go, okay? And for those of you who like FOIL or chose to try that this time, here we go. Let's show you how to do this with FOIL. So I'm just going to write it out this time. 4y minus 1 times y minus 2. First term times first term. 4y times y is 4y squared. The O stands for the outside terms. 4y times negative 2 is negative 8y. The I stands for, inner terms, my inside terms. Negative 1 times y is a negative 1y. And my L stands for last terms. Negative 1 times negative 2. Negative times a negative is positive. 1 times 2 is 2. Okay? All right. Again, I have some like terms to combine here. 4y squared minus 9y plus 2. Both of those answers match identically. Using the distributive property, you do have one extra line of writing, but again, you're going to see in the next video why that's going to be handy, but you can also use the FOIL method. Either one is perfectly acceptable, okay? Okay, last problem for this video. So if you guys would like to press pause, and then we'll check your answer when you get back. Okay, I hope that you had a chance to get that worked out. So these are getting just a little bit more complicated as we go. So again, if I'm going to use the distributive property, 5k is going to get multiplied by this entire set of parentheses in the back. Now my plus 2 gets written down, and now I have to multiply that times this entire set of parentheses. Okie doke. And we start distributing. 5 times 2 is 10. K times k is k squared. 5 times negative 7 is negative 35. And then we have that k on there that we have to continue to keep in that term. Now we start distributing this second item through my set of parentheses. So 2 times 2k, that's a plus of course. 2 times 2 is 4, and then we still have that k on there. 2 times negative 7 is negative 14. Again, hopefully you're picking up on a pattern here. We've got some like terms in the middle to combine. One of them is negative, wearing the negative uniform. The other one is wearing the positive uniform. They are going to battle one another, right? So this is a battle. They're working against each other. So what we have to ask ourselves is, well, who's going to win the battle? Well, negatives are, because there's a whole bunch more of them, right? And how much are they going to win by? They're going to win by 31. There's 31 more negatives than there are positives, so this becomes negative 31k. And then my minus 14 at the end, and there we go. All right. For those of you who are interested in seeing this foiled out, remember first, outer, inner, last. Okay, here we go. First means the first term times the first term. 5 times 2 is 10, and k times k is k squared. Outer, 5k times negative 7, positive times negative is negative, 5 times 7 is 35, and then we have that k that's multiplied in there as well. Inner or inside terms, that means I'm going to multiply these two that are closest together on the inside of this whole thing. So 2 times 2 is 4, that's positive of course, and then we have that k being multiplied in there. And then I have my last terms, right? 2 times negative 7, negative 14. Again, I have some like terms to combine. And I get the exact same thing, okay? By the way, I used to teach this a long time ago. I used to teach the distributive property to a bunch of 8th graders, and we lovingly referred to the FOIL method as the happy face theorem because it kind of looks like a happy face on there. So anyway, now you're in on the secret. FOIL actually is called the happy face theorem by some of us, not most of us in the world, but a few of us. So anyway, there you go. All right, I hope you guys found this helpful, and if you have any questions, please let me know. Thanks for watching. Bye-bye.